Okay, everyone, welcome to the next day of the month of ML, day 11, I believe, and this is a tutorial on object detection. So using what we've done in the past few sessions, residual networks, convolutional neural networks, and building data sets. Today we're gonna use a dataset called the Stanford 40 dataset, which is a dataset of images with the coordinates of boxes which bound certain objects within them. So firstly we'll build that dataset and then take a look at the data and understand it, and then we'll build a convolutional neural network to do the actual object detection in there. So we'll just make a new Python file from scratch. We'll call it day underscore 11 detection. Okay, so firstly, so what we've got is in this folder I've got called data. There's two folders. One of them is all of the images in this data set, for example this one, and they're labeled with that. So it's a data set of people doing certain actions, and the name of each file is firstly the action they're doing, and then the index of the example from that class, and then here's the images. But then also along with the images, there's this annotations file, and so if we go to that same one, applauding underscore 012, what you see is this, and these are basically annotations for this example in the dataset. So it's just like a tree of different attributes about that example. So the first thing, everything inside this annotation tag is obviously part of the annotation. And in that annotation, you've got the file name, you've got the folder it's in, you've got the annotations about the actual object, and within there you've got you've got the action they're performing, and then you've got the bounding box. And so this is the part that we are going to be using today. So basically, it's got the xmax, xmin, ymax, and ymin. So if you think about the image which we're going to be getting, within that there's going to be some box which bounds a person, and what these are the this is the furthest x position, it's the closest x position, the furthest y position, and the closest y position as well. So now we know that. Let's try and basically build some stuff around this to try and both firstly visualize it and then to do the detection. So we'll just close that. Okay, so we are going to firstly, what we're going to need, we're going to need NumPy probably somewhere. So we'll import NumPy. What else are we going to do? Let's just try and do it. So we'll have this class, we'll call it S40 dataset. We will also import from torch.utils.data, we'll import dataset and data loader. I'll be using them later. So we've got this class Stanford 40 dataset. So we'll define what actually happens when we create an instance of this dataset. Well, we want to get all of the images and the annotations, and then basically have them in two lists where the appropriate index element in the annotations and the images match up, and then form a full example, which is an image with a bounding box. So we'll say self.images, or we'll say image, let's say image underscore file paths is equal to, well, we want to list all of the file paths in this folder. Okay, so all of these ones in this images folder. Well, we're here, so this data is in the same folder as we are. So what we'll do, tell you what we'll do, we'll say image root. So the root directory for the images, well, that is in data / images. Okay, and then we'll say annotation root is equal to data / annotations. Okay, and then what we'll do is we will. Okay, cool. So how do we list the files in a folder? Let's have a look. All right. List all files in the directory. Well, here you go. I know this is what we want. So we want os.listdir. So that's from the operating system library is a function called list directory. You pass it the directory that you want to list, and it lists you all of the files in there. So we'll need to import os, and then we'll just do self image file path equals os.listdir in the image root. Okay, then we'll do self annotation underscore file paths is equal to os list directory of the annotation root. And once we've done that, let's just print the we'll print that image file path, print the first one, and then we'll print the second, and then we'll print the first annotation file path as well. And then we'll just run that. So we'll instantiate the dataset. So then if we run that, cool, right? So we've got this first file name for the images, cooking 106, and then we've got this other different file name, taking photos 180, right? So, well, why are they different? Let's have a look. So what we could do is so why does that come out like that? Strange. So applauding 001 is the first one, and applauding 001 is there as well. So why have they listed in different orders? Okay, well, what we can do is we can just do sort or sorted, is it? Yeah, sorted, and then that will sort them. Well, it takes in some iterable, something like a list, which has different elements which we can iterate over, and then if they're string elements, it lists them alphabetically, and if they're numerical, it lists them in order from decreasing to increasing. So run that again. Cool. Well, now we've got the associated XML file, that tree tag file with the appropriate image. Okay, so now, well, basically we need to define those two things when we're making a PyTorch dataset. So, as is here. So we'll define how to get the item. So get the item, I prefer to have that as the index. And then what we'll say is that when we get the item, well, the first thing we want is the image. So that's self.image file paths. Which image? Well, the one at this index. But this isn't actually the image yet. It's just the image file path. So it's just this string. Okay. So we actually want to get the image from that. So we'll do image is equal to. Well, we want to open that as an image. Okay. So firstly, we're going to import PIL. Well, we're going to import from PIL. We're going to import the image module. And so now we can do image dot open this image here, which is the image file path. Okay. And then we'll just do image dot show to check that's working correctly. And then the second thing we want is the annotation, right? So we want the bounding box. So the first thing we'll do there is we'll do we want to read that, don't we? So we'll do with open. So we're going to open this file. So we'll say we'll say bound box. We'll say bound box is equal to self dot annotation file paths of that index. So get the annotation at that index, and then we'll open that bound box in read mode. Although actually I bet there's a good library for reading XML files, so let's just have a look at that first. Read XML elementary. Okay. So let's see that. Okay, yeah, cool. All right. So we're going to use this library, which looks like it can parse XML data. So what we'll do is we'll do this. So we'll import xml.etree.elementary as et in our folder here. Okay, and then we'll forget about that. Then we'll do something like tree is equal to, we're just sticking with the theme, let's just keep the same name. So bounding box from the annotation file path, it will then become, we'll do et dot parse, and then pass it the name of the bound box. So this is and then this is the okay. So then we'll do well, now how do we get that item from there? So if we look back at our annotation, well, what we have is something like this, right? So we want to get these four things basically in a list. So let's do, if we look at how to okay, cool. Yeah, so we did this, right? So we passed that data. That's how we'd get the root. And okay, so find, that's probably what we want, isn't it? So we had elementary, yeah, so let's try and just do dot find on that. So we'll do bound box dot find, yeah, so it's got that find method. And then we'll try bound box because that was the name of the tag. Let's run that, see what happens. so let's get the first element from the dataset. Oh, okay, right, yeah. So, well, one thing we're doing is we're only reading. We are trying to open, when we do this open here, we're trying to open the file path without the data/images first. So what we actually need to do is get these this file paths and then append those things onto it. So we'll do image file paths is equal to, well, we'll do a list comprehension. So we can say we'll do image root plus item for item in self dot image file paths. Okay. Actually, we'll do that in a cleaner way. We'll do os.path.join. So we'll join together the image root and then the item. Well, the file path. Okay. Then we'll just copy that and basically do the same thing for the annotations. Get the annotation file paths. We'll join the annotation root with everything that's in the annotation file paths. Okay, cool. So run that. All right, there we go. So it's shown us this first image. We've done image.show, but we got none for the when we tried to print that part of the tag. So what's happening there? Let's see if there's any better docs for this. So maybe we've got to get the root first. And then from that root we should be able to find the bounding box there. No. Okay. Just put what we've got there. So we've got that elementary object. What have we got when we get the root? Okay, so yeah, we've got this annotation element, which is this thing. But then we're doing find all. It's not really working. Okay. If we use that doesn't like that, does it? That's the usual syntax for something called XPath, which is a way to search through XML tags. But if we can't find the element like that, how are we going to do it? So we get the tag string by the tag attribute. So if we did if we printed that annotation tag, well, that's just the name of the tag there. Yeah. Okay. So what else can we get? We're going to want to get this text content later, but firstly we need to get these elements. searching for sub-elements. Find the first sub-element that matches the given pattern. So let's just do, we'll do so we'll do get children just to see the children of that annotation object. Yeah, cool. So then we've got file name, folder, object, and this is the one which we want. So let's just do find all here and see if that prints everything which is a child. No, it requires a path for that. Well, let's try and do object. So we can get the object. We can get the object when we do boundbox.findAll. So if we do find, that won't return us a list, it will just return us the element. So that's that element which we're after. But it doesn't look like we can find elements directly which aren't direct children from that. So the boundbox tag which we want is actually not a direct child of this annotation tag, it's a child of that child. So I don't think we can find it. If we run that, yeah, we get none. So what we'll do instead is we'll just get that, we will find that object. So we'll just find that object, and then we'll do boundbox is equal to boundbox dot find boundbox, and then we'll print that boundbox dot text just to show us what's in there. Just print the boundbox first. Get rid of this showing the object. Yeah, cool, we've got that bounding box element. That's that. And then we should be able to, so yeah, well, then we'll get, so the children of that bounding box element will be xmax, xmin, ymax, ymin. So we should be able to say ymax, sorry, wait, is it xmax or yeah, xmax, xmin. So we'll do xmax, xmin, ymax, ymin is equal to boundbox.children. So that boundbox.children should probably, let's just stop that for a second, let's not do that right yet. Let's do boundbox.children. Cool, so if we print that, what do we get? It's got no attribute children, apparently. Get children. Yeah, cool. So it's got these four elements: xmax, xmin, ymax, and ymin in. Okay, and we've got these four elements in a list, but we actually don't want the element, do we? We want the actual text of that element, and then we can say xmax, xmin, ymax, ymin is equal to, well, let's have a list comprehension. But for everything in that boundbox.children, we'll do, so we'll get that like the value for value in boundbox.children. Well, we'll get more like element. So for every element in that list there, which is the xmax, min, ymax, ymin, we don't want the element, but we want the element dot the text. So then we should be able to print xmax, space x min, ymax, ymin. Okay, run that. Has no attribute children, has no attribute get children. Run that get children. Cool, right? So now we've extracted from this image the maximum x position, the minimum x position, the maximum y, and the maximum and the max the min y. Okay, so let's try and put those on that image. So so using pill, we want to show rectangle. Draw a rectangle, not text, but we just want to draw the rectangle. Okay, so what do we need to do? We need to what we're going to do is we're going to basically create this image draw object. So image draw module. So what we can do is we can basically do a drawing on the image we've got. So this is just something we've got earlier. So we did image.open to open the file when we're reading it, to return it from as an element from the dataset, and then we'll just we're going to draw on that, and then we're going to do something like draw.rectangle. Yeah. So here's all the methods it's got. Should have one rectangle. There you go. So we'll be able to do that object.rectangle and then specify the x min, y min, x max, y max to draw on that. Okay, so we will say so we've got img.open image there, and then we can say, so let's do that drawing. So we'll say how do we want to do that? Draw is equal to image draw. So we'll have a drawing which is equal to image draw. So we'll import image draw. We'll do image draw dot draw on that image, and then we'll do draw dot rectangle, which is going to take a tuple of x min, y min, x max, y max. Okay. Alright, and then so we'll just show the image at the end of that. It must be a real number, not a string. So I guess these have been returned as strings, not numbers. So we will also do, if we just copy, so we'll get that text, but we know they're all integers, so we can just convert them from string into int, and then run that. And there you go. So that's what the that's one example from that data set looks like. Okay, so those coordinates specify the bounding box within the image, and basically what we're going to try and do is we're going to build a convolutional neural network designed to detect a single object in an image. And what it's going to have is we're going to have, the usual convolutional layers that we had before, and then finally it's going to go down to 4 units. It's going to output 4 units, and what we're going to try and have them as is something like x max, x min, y max, y min. Or what can actually be easier to learn, what we'll try and implement will be to predict the center x, center y, and then the width and the height of the box. Okay, cool. So so now what do we want to do? Well, when we get the item, we don't actually, we definitely don't want to show it every time we're loading a new image in. So let's just let's define another function, show, and then we'll show the index, and then we'll put this stuff in there. So we still want to get all of that. So actually, let's just show the show that example. So we'll show an example And what that means is we're going to pass into this function an example of the image and the bound box, and then we'll do so we won't need to plot those boxes when we're getting the item. So what we've done is we've just we've got the image and we've got the and we have the Xmax, the bounding box there. So then we'll return that. That's what we want. That's the actual example. So we'll return the image, and then we'll return. Let's return something called bounding box, and then we'll set bound box equal to xmax, xmin, ymax, ymin. Okay. So, well, do we want to return the xmax, xmin, ymax, ymin? Well, if we want to predict the center positions and the width and the height rather than the top right corner and bottom left corner, well then we should change these. Okay. So what we should do is we should instead first calculate this thing. So we'll say the height of the box is equal to ymax minus ymin. We'll say the width is equal to the xmax minus the xmin. We'll say that the x center position is equal to xmax. Well, so what that's going to be is going to be xmin plus the width over 2. Okay. Alright, and then we'll say the y position is equal to ymin plus the height over 2. Okay, and then we just want to return, we're going to return x, y, width, and then height. Okay, cool. So we'll return a list of we'll return a list of those items. Okay, cool. So when we show, we're going to need to convert back from that thing as well. So that's not going to be quite right. We're going to have x, y, width and height. That's what comes out of the bounding box. And then when we show that, we need to convert that back into the xmax, xmin, ymax, and ymin. Okay, well, we're going to need to so xmax is equal to that's going to be x plus w over 2. And then we're going to have ymax being equal to y plus the height over 2. And then we'll have xmin equal to the center x position minus the width over 2. And then we'll have ymin equal to y minus the center y position minus the height over 2. Okay. And then we'll do cool, and then that should work. So we will do so we'll get an example, first element in the dataset, and then what we'll do is we will get the and we'll show that example. So we'll say dataset.show example, and then see if this works. What's going to happen now? There you go. Again, cool. That's good. So now we have the get item. It returns us those coordinates which we want. The center position, x and y, and then the width and height of the box, and that's what we're going to try and regress with the neural network. So we're just going to use a mean squared error loss to try and minimize the difference between our predictions of those four things and the labels we have for every example. Okay, so we want the data set with a capital, don't we? Yeah, not that data loader. Okay, cool. So this data set will inherit from that data set, and when that happens, yeah, I think that's all right. We just need to define one other thing, don't we? So we need to define, well, what's the length of this data set? Well, it's just a return length of the self.image file path. So the number of images there are in the file path. Then that's the length of our data set. If you do download the Stanford 40 dataset, you can find it online. I think in some of the downloads, there's one file which will always give you an error when you try and read it, and that's because it's a grayscale image. For some reason, there's just one of those in the whole dataset. So what you just need to do is remove that, and then remove the associated, annotation file as well, and then you'll be good to go. Okay, cool. Alright, this is good. Looks nice. Well, now we've got the data set ready to go. We can try and, well, we'll create our data loader first. So we'll say train_loader is equal to the data loader, taking in that data set which you've got there. Well, actually, we can use that library we talked about before, didn't we? So we can import get data loaders. So that's from get data loaders. Import get data loaders. So remember we had this. So we had this AI utils library, which you can find on my GitHub. If you come to these AI utils, and there's one function in there, get data loaders, where you can just pass it a data set, and it will split the data set for you with these given split proportions. It will randomly split those data sets, and then we'll convert them to data loaders. So just to save us having to write that now, that's what we'll use down here. So we will do so we'll get the train data loader, get the validation loader, and we'll get the test data loader, and then we'll get data loaders from that data set. And then we should be good to go. Okay. So let's just have a look for I in train loader. We'll do example is equal to that item. So we're done with these. Let's stop that. And then we will do then we'll just break that, and then we'll say dataset.show the example there. Okay, yeah, right. So basically, when you create a data loader, basically what that's doing is stacking some tensors together, some torch tensors, and so they all need to have the same size, but they also obviously need to be tensors themselves. In our case, we've got these JPEG images, so we actually need to apply a transform to our data set. So we can say So we're going to put a transform in there, right? So we'll make our data set be able to take in some transform, which is going to take it's going to convert the pill images into torch tensors. So we'll say it's none by default, and then we'll import from torch vision. We will import transforms, and then what we can do is we can say my transforms is equal to so we can do transforms dot compose, and then what this takes in is a list of the or maybe just subsequent transforms which you want to apply to your input. So first thing we're going to do is we're going to transform to tensor. So we're going to do to tensor, and then we'll do transforms dot resize. So we're going to transform our pill image into a tensor, a torch tensor, and then we're going to resize it to some shape, let's say 64 by 64, and then so basically, yeah, so this is instantiating. So here we compose these things together. So we basically make some callable function called this callable object, my transforms, which firstly, it's called on some input, i.e. the image. What it does firstly is it converts it to a tensor by applying this object to that pill image, and then calling this resize instance on that object as well. So then we should be able to pass into that data set my transforms like that, and then so we've got the transform here, and then we'll say get item. What we will do is we need to convert that image. So we need to say if self.transform, let's define that transform here. So we'll say self.transform is equal to transform, which is that thing, which is none by default. So if there is a transform, so if it's not none, if we've given it something, i.e. we've told it, convert to a tensor and resize, for example, then we'll have to apply those transforms. So we'll do self.transform on the image. So we just want to transform that image. Okay. What else are we going to do? So let's try to run that now. Cool. And it takes 2 positional arguments, but 3 were given. For this one, yeah, that's because the size it takes in is not 2 arguments, but it's a tuple like that. It takes 2 positional arguments, but 3 were given. Take a look at that resize. What does that take in? Where'd that go? Okay, cool. So it takes in a sequence or an int. Torch vision.transforms size. Well, that should work, but in this case we can have it square, so it takes 2 positional arguments, but 3 were given. What's that talking about? Yeah, cool. So I think what this wants is is a list as an argument. Okay, cool. Yeah. All right. So here, all right. What we've done back here again. We have converted it to a tensor now when we've got the item. Okay, and then we've passed it to the show function. Now it's saying that isn't the show call, isn't it? Probably. This isn't resize. Oh, okay, right, yeah, so we need to resize the image first. So we need to resize it before we convert it to a tensor. Right. But we're going to get another problem now. Okay. So yeah, found class pill image when I was doing this. So for item in train loader, I was going through here, and then it tried to batch some items together, and it found that they were a pill image, so it couldn't couldn't batch them together. So why is that? Are we not returning the pill image? We're just returning. Yeah, so we're not actually saying the image equal to that self.transform. So now if there's a transformation being applied on this data set, well, what we're going to do is we're going to set the image equal to the transformed version of that. So in this case, it will have been resized down 64 by 64, and then it will be converted to a torch tensor. Okay, cool. Right. So now. What's this one? Okay, cool. Right, so this is in the show function. Okay, cool. Right, so first things first. This example, which is actually going to be so here. We're taking this first element in the training loader, and we're passing to that data set. Well, that first element, that's not an example, that's a batch of examples. So let's assume that we are going to take in batch, so we'll just call that B. Well then, this needs to know, this show function takes in a batch. But then we'll say, so we know that an example can be unpacked into the image in the bounding box, but we'll say that the example is equal to the first item in the batch. So when we try and show a batch, it'll just show us the first example in that batch. Okay. Now we're probably going to get more errors. Yeah, cool. So we'll just print that example. What is that? Print its shape instead. Well, it has shape 4 by 3 by 64 by 64. Okay, yeah, so we didn't want to get the first element because this batch is basically, if we print the batch, what you'll see is that is a tuple of two things. So it's a tuple, the first thing is the data, and the second thing is the label. So if we do batch 0, we're getting the data. Really what we want to do is we want to well, we'll say that the image is equal to oh wait, no, okay, we'll say, yeah, we'll say we'll say the image in the bound box reach equal to the example, but then we'll say image is equal to the image, so the first item in the image that's unpacked there. And then we'll say the bounding box is also equal to the first thing which appears in that bounding box. Okay. We'll run that. Okay, cool. So now what's happening? We're getting a bit further, but now we've got this in the show function. We've got this image, and we're not going to be able to show it because we can't do image.show on it because it's a tensor still. So we need to say something like we'll just go down here, and then we'll say if self.transform again. So it's been transformed from a pill image. Then what we need to do is we'll define another thing here. We'll say unloader is equal to transforms.compose, taking in a list, the first thing. So when we want to unload that image after it's been a tensor, what we will do is we'll do transforms.toPillImage, and then we'll do transforms.resize to the original size. I'm not really sure what the original size was. I don't know, let's leave that for now. So it'll probably come out a bit smaller than it went in. So we've got that unloader, and then we'll say if there's a self.transform, then we need to, we'll do image is equal to unloader on the image. Okay, and okay, let's see what happens now. Tensor has no object load. Okay, so we still, yeah, we can't be doing that yet. So as soon as we get the image, let's convert it back. Okay, there we go. Right, so it's tiny. Now what we can see is that we've shown this image, and we've also tried to plot this rectangle on it, right? But now that we've resized it, well, we didn't proportionally resize the x max and the x min, etc. So so what happened is that those the bounding box coordinates are still on, like, so this is like, you know, the x. Is this the so yeah, we've returned from our get item, we returned x, y, width and height. So that's x, y, width and height. Well, now even the you know, the x position is 112. Well, if we've downsized our object to 64, well then this is no longer the right label and no longer the right coordinate for us to show the bounding box on. So we're going to have to adjust that, and we'll do that by just manipulating those values further in this code here. But it's almost time to go, and so I think we'll save that for another day where we continue building this data set, so so we can go fully through that later. So I think we'll have that tomorrow, and yeah, thank you for attending. If there was any questions, let me know in the chat, and we can answer that. Otherwise, I'll comment all of this code and then and get it out to you on the GitHub. So thanks for attending. Another day, another hustle. Peace out.